Final topic in further functions is a mix of families and literal equation problems. So let's get stuck into a couple of variations of them. So we've got a function here, f of x equals mx plus 4, and this is a family of linear functions which all have the same y-intercept and a different gradient, or a parameter as a gradient. So let's find the x-intercept, which occurs when y is equal to 0. That means mx is equal to -2, x is equal to -2 on m. So there's our x-intercept for the family, -2 on m, comma 0. For which values of m is the x-axis intercept less than -2? So here is the x-axis intercept. We want that to be less than -2. So -2 less than -2m, -2m greater than -2, divide by -2m less than 1. So this seems to suggest that the x-axis intercept will be less than -2 when m is less than 1, but not quite, okay? So if m is equal to 0, have a look at what happens to the x-axis intercept. You're going to get -2 divided by 0, which is undefined, okay? And that means that you won't have an x-intercept, so that doesn't meet the requirements. So we know also that m can't be equal to 0. What about if m is less than 0? Well, that's a negative number, and a negative number divided by a negative number is a positive number. So m actually can't be less than 0, or less than or equal to 0. So this seems to suggest that m is less than 1 algebraically, but truth be told, it can only produce values less than -2 as an x-intercept if m is less than 1 and m is greater than 0, right? Because it has to be a positive number, and the positive number has to be less than 1 for this to stay negative. So we'll summarize this by saying, for which values of m is an element between 0 and 1, not inclusive of the endpoints. Right, let's see what that might look like as a graph. m times x plus 2. And we use the parameter feature of this to test it. So here m is -2.6. And of course, we said that m is an element of 0 and 1 to produce an x-axis intercept less than -2. So we can see here that that's why it doesn't meet the requirements. It's negative, and a negative divided by a negative is a positive. So if I start to increase this, so it's still positive. When it hits 0, what I should get is no x-intercept. And there we go. And when it's between 0 and 1, i.e. 0.2, yep, negative, below -2, below -2, below -2, and as I hit 1, what it will be is -2 exactly, and then it'll be above it. All right, so confirming that. All right, so find the inverse function for f. So f of x is equal to mx plus 2. We go let y equal that, swap x and y. So x is equal to my plus 2. X take 2 equals my. Y equals x take 2 over m. So f -1 x is equal to x on m take away 2 on m. Find the equation of the line perpendicular to the graph at the point with the coordinates 0, 2. All right, so that will be, so my original function is f of x equals mx plus 2. So its gradient is m. So if we're looking for the line perpendicular, it'll be the negative reciprocal of m1. And so our function will be y equals -1 mx, and it's got to go through the y-intercept 2, so it'll be that. So if I basically graph that, let's just see what happens. What it should produce is a graph that's perpendicular that runs through there. Let's just see whether that happens. -x on m plus 2 and graph. All right, and as I move M around, what should happen is it's always going to be perpendicular. And it's always going to go through 0, 2. Nice. All right, the graph of a quadratic function passes through the points 1, 6 and 2, 4. Find the coefficients of the quadratic rule in terms of C, the y-axis intercept of the graph. All right, so we want to use the rule y equals ax squared plus bx plus c, and the y-intercept we're noting is c. All right, so what we'll do is we'll set up our equations, and what we'll be able to do is find these coefficients a and b in terms of c. All right, so you can sort of see how that's going to happen by subbing in the points, but let's just do it and see what happens. 6 equals a plus b, so I've just put 1 in for x and 6 on for y. A plus b plus c. Now, a second one will be 4 equals 4a plus 2b. We get that right? 2 goes in for x, yeah, plus c. Alrighty. So what I'm going to do is when I state either a or b, I'm allowed to state it in terms of c because that's what this question says. So what I'm going to do is run an elimination. I'm going to eliminate b, and that will get me a, which I can then transpose to make it in terms of c. So I'm going to basically multiply all of this by 2. Let's form our function, which is 12 equals 2a plus 2b plus 2c. All right, so let's subtract now, and I'm going to get negative 8 equals 2a. That is eliminated. Take c. So this is going to be negative 8 plus c equals 2a. Now what we're going to do is find a in terms of c. So a is equal to c take 8 all over 2. Okay. All right, so that's the first coefficient found. Okay, so that's this a coefficient here. Let's find the b coefficient. So I'm simply going to put a in that first equation. So 6 equals c take 8 all over 2 plus b plus c. All right, let's multiply everything by 2. C take 8 plus 2b plus 2c. 20 equals 3c plus 2b. What am I making it in terms of c? So that's going to be 20 take 3c all over 2 equals b. All right, so there is my b. It is 20 take 3c all over 2. All right, probably can do that on the calculator as well. So let's try that out and see what it says. So we're going to go and do a simultaneous equation where we've got a times x. We'll go 6 equals a plus b plus c, and 4 equals 4a plus 2b plus c. And we're solving for a and b. We want to find out what a and b are. All right, and a is equal to c take 8 on 2, so that checks out. This one here, what have they done? Just yanked a negative out. All right, yep, so there you go. All right, got a transformation here defined by this matrix where a is this. All right, so let's just start. I'll solve the equation for x. That's this matrix equation. All right, so I suspect you won't have to do this in a Year 12 methods exam, but anyway, let's go back and do a bit of Year 10 matrices here. Ax plus c equals x dash, and we want to solve it for x. Now, what we can do is subtract this matrix here, so that is x dash takes c. Now, notice that we want to make x the subject here, so we want to get rid of this A matrix here. Now, I don't know whether you remember almost 2 years ago, either me or someone else explaining to you that actually we can't divide matrices, that operation doesn't work. So what we do is we go x equals, and because this A matrix here is pre or before the matrix we're trying to solve for, we pre-multiply on this side by the inverse. X dash takes C. All right, so I don't know whether you'll remember that, and actually, in truth, that really doesn't quite matter. Okay, I'm going to show you. This is more like a question that we'll get this year. Find the image of the curve with the equation y equals 1 on x under this transformation. Let's write in our actual equation. So it's A, which is 5, 0, 0, k, x, which is this matrix here, x, y, plus the c, noting that there's no brackets there, so it's dilate, reflect, and then translate. So 5, 2 equals x dash, y dash. All right, so the aim will be now to get this out of matrix form. So I'm just going to use matrix multiplication, which is 5x plus 5 equals x dash, and ky plus 2 equals y dash. All right, so I want to sub for y and x. That means I need to make x and y the subject, not x dash. So I'm going to go and say x is equal to x dash take 5 on 5. And y is equal to y dash take 2 over k. Okay, let's pop them in now. So I've got y take 2 on k. So I've basically just subbed that in place of y and drop the dash at the same time, equals 1 over x, which is x take 5 on 5. So where I've seen x there, I've popped it in and dropped the dash as well. All right, so that's going to be y take 2 equals k over x take 5 over 5. That's divided by that, so it's multiplied by the reciprocal of that. So that's going to be y take 2 equals 5k over x take 5. And that's going to be then y equals 5k over x take 5 plus 2. Right, find the value of k if the image passes through the origin. So there's my function or my transform function there. And what we want to have is the value of k if it passes through the origin. So that is 0, 0. So that's x is 0, y is 0. So let's pop that into this equation here, and that will allow us to solve for k. So we're going to go 0 equals 5k over 0 take 5 is negative 5 plus 2. That's going to be 0 equals negative k plus 2. K is equal to 2. All right, so the value of k will be 2 if it passes through the origin. All right, so that is it for further functions. So 7E, and again, as always, a pretty tough chapter review from Cambridge.